In section 1.2, we're going to discuss the difference between an observational study and a design experiment, and we're going to explore a lot of the associated definitions with those two ideas. Now, these ideas are really important in Chapter 4, which is about the difference between two variables, and Chapter 11, which is about the difference between two populations. And since it's important in two different sections, there's a very good chance it might show up on the final. Hint, hint, hint. All right, so response variable, let's begin, is the particular quantity that was asked a question about in our study. In other words, it's what you're trying to find out about. What are you trying to learn? So it could be something like in medicine, let's say about the disease rate in a country or the disease rate in a particular area. Or it could be about the T cell count in HIV positive patients, etc. It could be about, in education, about final exam scores. How could I make it so that I have a final exam score that is different? Could I raise them? Could I lower them? The response variable is the final exam score. Now, explanatory variable is any factor that can influence that response variable. It's also called a predictor variable or a factor because it's a factor that influences the response variable. It's something that you think might have an impact on that variable. So if we stick with our final exam example, what are some things that could affect the final exam score? Well, let's think sleep, diet, how much you study, that'd just be a few. So how much you slept the night before, that's an explanatory variable. How much you slept the week before, that's an explanatory variable. What you ate the night before, what you ate the morning of, etc. Those are explanatory variables. Now, level is just the number of different options that the explanatory variable can have. So if we ask the students going into the final exam as they walk into the room, how many hours of sleep did you get last night? And it goes from a low of 0 to a high of 10 hours. Somebody really slept. Then it has 11 different levels because 0 hour, 1 hour, 2 hour, 3 hours, all the way up to 10 hours. And I'd round to the nearest hour. So that way I'd have 11 levels. So it's just the number of different options that are possible for that explanatory variable. If you're talking about medicine, let's say there's an option for a 2-shot vaccine or a 3-shot vaccine, saying the third one's a booster or something. And you can say, okay, how many people had 2 shots, how many people had 3 shots, and what was the difference in the disease rate in that area. Now, a treatment is a very special kind of explanatory variable. A treatment is an explanatory variable that takes the form of a purposeful intervention in a designed experiment. We're getting the cart a little bit before the horse, but you can imagine what we're talking about here, which is that the researchers actually purposely intervene. So let's say as you walk into the final exam, they hand randomly half the students a cup of coffee and the other half of students do not get a cup of coffee to take into the exam. So that coffee, that's an explanatory variable. There's 2 levels, having coffee, not having coffee. And because the researchers purposely intervened with that coffee, it's a special kind of explanatory variable called a treatment, as opposed to any old response variable. So what the student chose to eat that morning, that's explanatory because the student chose it, right? It's an explanatory variable because it might affect what's going on, but it's not a treatment because the student chose it. A treatment is something that the researcher chooses for the patient, for the student, for the subject of the study. And you can see we're already dancing around the distinctions that we have between just any old explanatory variable and a treatment. So a treatment is a special kind of explanatory variable. It's an explanatory variable that the researchers are able to purposefully intervene with. All right, so that leads us to the different kinds of data collection that we can have. So there are 3 different types. There's a census, which is when you try to ask everybody and every member of a population. So in most studies, this is not really practical because it's really hard to get a hold of every single person. It's really expensive. It takes a lot of time. The U.S. Census, for example, spends a good year trying to get in touch with everybody, and it does not do it. It never has. It always fails to reach the poor, the disadvantaged, etc. Now, the age of inauguration of every U.S. president, that we could do because there's only 44 of them as I'm saying this right now. There might be 45 by the time you watch this, but currently there's 44 presidents. We know their ages. We know the age of every single one of them at inauguration, so it's not hard to do a census. So for a small population, censuses are possible. But for a large population, it's very, very, very tough to do. One of the largest and most well-funded one is the U.S. Census, and it isn't actually a census. It does its best, but it is not actually getting a hold of everybody. But hypothetically speaking, that's what a census is. You get a hold of everybody and you ask them something. All right, so a census is a very special kind of observational study because an observational study measures the value of a response variable without attempting to influence the value of either the response or explanatory variables. So the researcher observes the behavior of the individuals, but it does not influence their outcomes. So surveys fall into this. The census, the U.S. Census, is an example of this. You're able to ask some people what they think. You're able to observe their behaviors. You're able to go explore records. All of those kinds of things are observational studies. So, for example, suppose you want to study whether adult smoking affects children, or do malnourished children have difficulties making friends? Well, you would never want to do an experiment on these things. You don't want to have, purposely intervene and force adults to smoke around their children, or force people to malnourish their children, right? You want to just observe what happens if you know a child is malnourished. Does that affect their ability to make friends? Do students who sleep well the night before an exam perform better? It's very difficult to intervene and force people to sleep, right? So, but you could ask them, how many hours did you sleep when you walked in? So often we have to use observational studies if it's unethical, for example, to do an experiment. For example, the adults smoking affecting their children. That would be completely unethical to force adults to smoke around their children. So that would be terrible. But you could ask people, do you smoke? Do you have children? Right? And you could observe what types of behaviors you see in those children. You could find research on how much nutrition children are getting. Do the students qualify for free and reduced lunch, etc., etc.? Do their doctors count them as malnourished? And do those doctors, if you research those records, do the malnourished children also report having difficulty making friends? So it'd be tricky to get at, but you definitely could never do an experiment on this because experiments, which is what I'm about to talk about, require the researcher to influence what's happening. I'm going to change what I originally wrote there to more match what the textbook writes because I like it better. I don't particularly like the use of the word controlled in the old definitions, so I'm sorry. I'm changing this for right now. So future students, this won't be a problem because I will change it in the notes. But if you're currently watching in fall of 2017, you'll have to change this. So a study in which a researcher assigns the individuals in a study to a certain group intentionally changes the value of the explanatory variable. So they're purposely doing something. So for example, they randomly assign students to the coffee group or the non-coffee group, and they intentionally change the value of that coffee. So some students get the extra shot of coffee going into the exam, some students do not. And then records the value of the response variable for each group. What were the final exam scores for each of those groups? That's a designed experiment. So does aspirin make distance runners move faster? So you could give some distance runners aspirin, some distance runners not aspirin, and randomly assign them and then record their distance and time. Does the color purple attract the opposite sex? So you could have some people wear purple, some people not wear purple, and see how many people, are approached at a bar, for example. Does sleep deprivation make students perform worse on a statistics exam? So you could deprive people of sleep. Be a little bit unethical, but as long as the statistics exam is not worth any points for the course, then maybe it'd be fine. So sleep deprivation, so make some students stay awake, let the other students sleep, and then see who performs worse on the statistics exam. So those would be designed experiments. The researcher is assigning individuals to a certain group, hopefully randomly, intentionally changes the value of an explanatory variable. That is affecting some kind of influence by the researcher. The researcher is influencing what the person is doing, what the person's taking, how much they're sleeping, etc. And then records the value of the response variable and to note any differences. So now let's explore those definitions in an example and see if we can get our hands around what's going on here, or minds around what's going on here. So example 1, for each of the following research scenarios, determine the explanatory and response variables in the following. Determine the number of levels possible for the explanatory variable. and determine the type of research being done. Is it a census? Is it observational? Is it a designed experiment? So in the first one, a food scientist wants to compare the flavor of McDonald's fries made with beef tallow, which is the original method until 1990, back when I was a child, and vegetable oil, which is the current method. They use identical potatoes and cooking times to make the fries. The fries are then numbered, and a group of people who don't know which is which taste test them and rate them on a variety of traits such as flavor, texture, crispiness, on a scale from 1 to 10. Alright, so now the explanatory variable is obviously the frying method. So, or the cooking oil, if you will, that they're using to do this. And the response variable, well, it's a little bit complicated, but it's basically taste, right? So flavor, texture, crispiness, how do they taste? So I just wrote that up for us. Now, how many levels did the explanatory variable have? Well, there were two levels, the beef tallow versus the current method, so vegetable oil. So that'd be two explanatory variable levels. Then determine the type of research being done. Well, this is very obviously a designed experiment. So they're purposefully giving people two different kinds of things. This is actually a special kind of design experiment called a matched pairs study design experiment, where you have kind of a before and after. You have either this or this, and you're comparing the two of them. So we'll get more into that a little bit later, but it's a design experiment of two different things. So this is going to be two batches made. Everybody was given a different type of fry to taste. They were given both different types, as a matter of fact, and then the people actually are comparing the two. It's the classic Coke versus Pepsi, Colgate versus Crest toothpaste, etc. So they give them both to them. But the researchers did the frying, the researchers influenced them. These people would never have tried the two different methods without the researchers' influence. So therefore, it's a designed experiment. All right, now a Jackson College researcher wants to measure whether the campus a student takes the majority of their courses, so I picked Jackson, Lenawee, or Hillsdale, those are our three main campuses, has an impact on completion rate. So do they obtain a degree or certificate? The researcher gathers the records for all students and compares the percentage of students that obtain a degree for those locations. Now the key to this is this word right here, all. Right? That word right there is a cue that this is going to be a census, because they are actually getting the records for all the students. But we're getting ahead of ourselves a little bit. So we have explanatory and response. So the explanatory variable is the campus that they're on. Right? So campus is explanatory. The response is the completion of the degree. All right, do they obtain the degree or not? All right, then what about the explanatory levels? Well, there's three that are listed, the Jackson, Lenawee, and Hillsdale. Now, technically, we do have another, we have a couple satellites. So, for example, the North Campus, which is the Maher campus, or some students take their classes in the prison, some students take their classes in high schools, etc. But let's stick with these three as our three main levels for this particular problem. And I imagine that any Maher campus students would be folded into the Jackson area ones, and so on. So for us, there's three levels, Jackson, Lenawee, and Hillsdale, and the census is what it was being done here, because this is all the student records. That key is that word all. Right? When you see that, then you know that it's talking about trying to gather everybody. So a census can be gathering a hold of every person and asking them a question, but it could also be just gathering all the records, all of them. All right, last but not least, what about a group of middle school students want to know if they can use their height to predict age? They take a random sample of 50 people at their school, and both teachers and students, and they record each individual's height and age. Well, the explanatory is height and the response is age. And the key to that is the word to predict. So since they say to predict age right there, that means that they want to have age be the response variable. And height is what they're using to try to predict that response variable. So the explanatory is height, the response is age. Now, level is a little bit strange here, because height actually takes on a lot of different values. So you could think of it as one level, just height, or you could think of it as, and we'll get, we already learned this in section 1.1, but you could think of it as having infinitely many different levels because there's infinitely many different heights since height is a continuous variable. As a matter of fact, let's write that instead. So there's infinitely many levels because height is a continuous variable. Now that said, whenever you're doing a study like this, or speaking of which, this is an observational study, I'll put that in there right now. It's an observational study, but to be fair, they would probably group them by the nearest inch and the nearest centimeter. They're limited by whatever tool they're using to measure height. So nearest inch, nearest half inch, that kind of thing. But technically there's infinitely many levels because height is continuous. And the observational study is definitely what's being done here. We're not doing anything to influence people's age, not that you could. It's just measuring heights and measuring ages, and it's not everybody. If it was everybody at the school, then that would be more of a census. But since it's only a random sample of 50, then it's an observational study.